Hi everyone, this video is a preview to my 10-hour Udemy course on creating scalable web applications with Angular and ASP.NET Core web APIs. I have updated this course on Udemy to the latest versions of Angular and ASP.NET, and this course ranks among the top courses for Angular and ASP.NET Core web APIs. I have a coupon code for you all, and you can use this link that is in the description to get an instant discount. You don't have to buy the course, but watch the intro, go through the description, and then decide. With that said, enjoy this video and like and subscribe to my channel for more content like this one. Hi and welcome to this course where you will learn and master your ASP.NET Core and Angular skills by building a real-world application alongside me. My name is Samir and I will be your instructor for this course. Together, we will build an amazing real-world development blog application using Angular and ASP.NET Core web API from scratch. We will use Angular CLI to create our Angular application. We will use Bootstrap CSS to maintain a clean and consistent look. We will learn how to create components, which are the building blocks of any Angular application. We will build Angular services to make HTTP calls and learn CORS, use RxJS, observables, subjects, and subscriptions. We will perform CRUD operations, that is, create, read, update, and delete, by creating Angular forms in our application. We will also create a reusable image selector component and use it in multiple components in our application. Using the image selector, we will upload images to our web API and use it as our image selector. In the backend, we will build a REST web API using ASP.NET Core and Visual Studio. We will create a domain-driven design when creating our application. We will create new endpoints and action methods and perform CRUD operations on our domain models. We will use Entity Framework Core to create our database and tables using our domain models. We will build Entity Framework Core relationships between our domain models as well. We will also use repository pattern and asynchronous programming in our API. To protect our application, we will learn and build authentication and authorization in both the API and the UI application. We will use ASP.NET Core identity and create a JWT token from our API so that our Angular application can use this JWT token to make authenticated API calls. In our Angular application, we will use advanced techniques and build interceptors, auth guards, and much more. This will be an amazing tutorial by the end of which you will master creating scalable full-stack web applications using Angular and ASP.NET Core. So I hope you click the enroll button and join this journey with me. To make the best use of this course, you should have at least 3 months of experience working with ASP.NET Core and Angular. This course is not suitable for absolute beginners, and some knowledge of these languages and frameworks is required. Having said that, during the course, I will often cover several topics in detail with examples and best practices and provide some great tips and tricks. In the next few lectures, we will set up our development environment, that is, all the softwares and packages we need to run our course smoothly. In this lecture, we will download and install .NET SDK and .NET Runtime packages. The links for both of these are available in the notes attached to this lecture, so you can go ahead and use the download links to install .NET SDK and .NET Runtime to the versions shown in this video. In my browser, I will navigate to .NET.microsoft.com/en-us/download. And this will open a similar link over here. From here, you can select the .NET versions. For example, it is showing the .NET 7.0 version, which is a standard term support and is the recommended version. And this is the version that we are going to use in our course. Now you also have the option to install .NET 6. Now in here, we can right click on this link which says all .NET 7.0 downloads. So right click on here, open link in new tab. On this page, you have the option of choosing your operating system, which is Linux, Mac OS, Windows, and other ones. And also for the ASP.NET Core Runtime 7 versions, we also have a similar options over here. So in here, for example, my machine is a Windows machine. So inside Windows, I will choose x64 or x86 versions, whichever one is your machine. And similarly, on the runtime, I will choose Windows and the x64 or x86 versions, whichever your system is. From these download options, go on and download and install .NET SDK 7 version and .NET Runtime version 7 as well. In this video, we will download and install Visual Studio 2022 so that we can code our .NET solution. To download Visual Studio, navigate to visualstudio.microsoft.com in your browser. I will have this link available to you in the notes attached to this lecture as well. Scroll down on this page and choose the version of Visual Studio that you want to install. For Windows and Mac users, you can download their respective versions, and if you are a Linux user, you can download Visual Studio Code, which is a lightweight IDE, and you can install some packages for your C# and ASP.NET development. I am on a Windows platform, so I will choose the community version, which is free to use. This will download the Visual Studio installer. Click on continue and it will download the necessary files it needs to install Visual Studio. After that, you will get a setup that is similar to this one, where you can select and install various components inside Visual Studio. From this screen, I will first select the ASP.NET and Web Development package. I will then go on and select the .NET Desktop Development package as well. I will also select the Data Storage and Processing package to connect, develop and test the solutions with SQL Server and other SQL or data storage packages. So with these three packages selected, I will click on Install. And this will install Visual Studio 2022 into your system. In this video, we will download and install SQL Server, and we will also install SQL Server Management Studio. So I will come to this URL, microsoft.com/SQL Server/SQL Server downloads, and I will provide the links to both the downloads in the notes attached to this lecture. And on this page, I will come down to the developer section. And this is the SQL Server 2019 developer, and it's a free edition. So I will come here and click on the download now. And I will click on save. Once it is saved, I will click on the installed exe. And this has started the installation of the 2019 SQL Server Developer Edition. I will click on the basic version. Click on accept. And I will choose the same path. Click on install. The SQL Server has now been installed and it has brought you some information. We have the connection string over here. We have the SQL Server installed folder and some other information as well. We have to keep our focus towards this server information, which is localhost / Microsoft SQL Server 01. Yours could be something different. We will keep this information handy of what SQL Server instance we have installed on our machine. Yours could be something different, but keep this information handy because we will use this information later on to create a new database inside the SQL Server. So I would basically copy this information and keep it handy somewhere. From this window, you can also see it's written over here that we can install SSMS. It is the ID which is used to run SQL, and I can click on here, or I will also provide the link to download SSMS. So you can come to the link and you can click on this free download for SQL Server Management Studio SSMS. So you can come over here or click on the setup and click on install SSMS. So it comes to the same URL. So I will come here and click on this download and install SSMS. So it's asking me to save it. So I'll click on save. Once it has been downloaded, I will click on the setup and this will open the setup for me. I will click on install. The installation has now completed, and I will click on close, and I will open a SQL Server Management Studio, and it has opened the connect to server pop-up. And you can mention the server name that you installed, which was the instance name of the SQL Server. And if you remember it from the video, it was this. Yours could be something different. So I have pasted the one that SQL Server gave me. So I've copied it to the server name, and I will keep Windows authentication as my authentication mechanism. I will click on connect, and it has connected me to the SQL Server instance in my machine. And if your databases will come over here if there are any, and during the application we will create a new database as well. So you'll have to follow this SQL Server installation if you want to go ahead with creating a new web API. We will now download and install Visual Studio Code. So you can go to the website code.visualstudio.com, or you can Google for Visual Studio Code. And from here, you can download the version that is applicable to your machine. Once you have downloaded the software, you can install the software on your machine to run Visual Studio Code. During the Angular development process, we would need some Visual Studio Code extensions that would make our life easier during the development. The extensions that I have is ESLint from Microsoft. I also have Angular Snippets version 16 from John Papa. I have the CSS formatter. Then I have Angular Language Service, which is from Angular. I have the IntelliSense from CSS class names in HTML. And I also have the Path IntelliSense, which is a plugin that autocompletes file names. Now there may be some more plugins that are out there which can help you in some way. So you are totally free to download those and install them as an extension. So feel free to download and install any extensions that would make your life easier. To create the Angular application, we would need the latest version of Node.js in our system. So let's go to https://nodejs.org/English. And from here, you can come to the downloads section over here. And from the latest long-term support version, you can install or download and install the version that supports your system. So we have Windows installer, Mac installer, and source code as well. So click on the version to download it and install it inside your system. In the previous lecture, we installed Node.js into our computer. So to check that, we can now write node --version. Press enter. And if it comes with a version, that means we have Node.js installed in our system. Now it's time to install Angular CLI, which will be used to create the Angular application and further components and services as well. So here's the command for that, but you may have Angular CLI already installed in your system. A good way to check is using the command ng version. Press enter. It comes up with the Angular CLI command, and I have Angular CLI 16.0.2 installed in my system. Now, if you have Angular CLI installed in your system, but it is not the latest version, you can follow these steps. First of all, we'll write the command npm uninstall -g at Angular CLI. So Angular /CLI. Press enter, and this will uninstall Angular CLI. After this, we can now install Angular CLI's latest version. So I'll write the command npm install -g at Angular /CLI at latest. Press enter, and this will install the latest Angular CLI. Angular CLI has now been installed. Now, if you never had Angular CLI installed, you can just use this command, which is npm install -g and at Angular /CLI, and this will install Angular CLI for you. And to check the version, or to check if Angular CLI was successfully installed, you can close this command prompt or terminal window and open it one more time. So I'll open the command prompt or terminal window, and here I will write ng version. Press enter. And as you can see, I now have the latest Angular CLI version, that is 16.1.2. It is advisable that you follow the entire video and not skip any parts in between. Skipping a section could mean that you are missing out of key information that's required in the later part of the tutorial, and might result in you having errors. If you are still facing any issue, it is advised you either revisit the lecture again or search online for relevant help. Often the most common issues are solved by other fellow developers on websites and forums like Stack Overflow. As a developer, you should have the skill to look into an issue and try to find the solution of it by visiting various websites online or finding a solution on your own. This helps you as a developer to get more information and debugging knowledge that makes an essential part of becoming a good software developer. Welcome to section 2. In this section, we will create a new ASP.NET Core Web API using Visual Studio. Make sure you have followed the development setup videos before proceeding with the lectures. I have created a folder for myself, and that's under eDrive Udemy CodePulse. So CodePulse will be the name of the project that we are building, and that's going to be our coding blog application. And the coding blog application will reside under this folder. So you can create a folder for yourself in which you will create your API and UI projects. So in here, I will create two more folders, one for the API and one for the UI. So let's create a folder called API and another folder called UI. We won't be doing anything in the UI folder as of now, but we will create a new ASP.NET Core Web API in the API folder. So for that, let's open Visual Studio, and this is the Get Started window of Visual Studio. To create a new project, we have this Create a New Project button on the right hand side. Click on that. This takes you to the next page from where you can choose a template for your project. For example, you can choose a web application, a web API, a Blazor server app, and many more. From the left hand side, you can see you have the recent project templates, and it might be empty if you're just starting out. But from here, I have the filters as C#, all platforms, and all project types. So if you have those filters, you'll be seeing similar options. And from here, I will select the option ASP.NET Core Web API, and that reads that this is a project template for creating an ASP.NET Core application with an example controller for a RESTful HTTP service. This template can also be used for an ASP.NET Core MVC, views, and controllers application, but for our purpose, we'll be using it for a web API. With that selected, I'll click on the next button. From this page, it is asking us to configure our new project. So we will give the project name, and you know the project name. We are calling our project CodePulse. So let's give it a name. So CodePulse, and because this is the API project, I will append the word .api to this. So the project name becomes CodePulse.api, and the solution name also becomes CodePulse.api. And we have to give a location in which we are going to store or create this API. And we have the folder right here. We want to create the API in the API folder. So I will go inside that and copy the path and come back and paste the location over here. So we are creating our project CodePulse.api inside the CodePulse application /API folder. And with that, I will click on the next button. Then Visual Studio asks us for additional information like the framework, authentication type, and other stuff. From the framework section, I have the .NET 7, which is the latest at the time of this video recording, and I will select that. And I will keep authentication type as none. I will keep this selected, which is configure for HTTPS, and I will have all the rest of the stuff as is. If you can't see .NET 7 in here, you have to make sure to follow the development setup videos, which are in section 1, to make sure you have installed .NET SDK and runtime, and also you have updated Visual Studio as per the latest version to have this over here. So I will select .NET 7 and click on this button, which will create a new ASP.NET Core Web API. It takes a few seconds for Visual Studio to create this new project, and it has given us a few files and folders over here in the Solution Explorer. If you can't see the Solution Explorer, you can go to the View and open Solution Explorer, and that is it over here. Let's come back in the next lecture and understand the files and folders created by Visual Studio as part of our Web API project. In this lecture, we will understand more about the project and the files that were created as part of the project scaffolding. Let's come back to Visual Studio. The left-hand side area will be mostly used by you to code your API. On the right-hand side, we have the Solution Explorer. If you by accident close the Solution Explorer, you can go back to it by going to the View menu and click on Solution Explorer. In the Solution Explorer, we can see the files and folders that Visual Studio created as part of the Web API template. Let's understand them one by one. On the top over here, we have the solution file. A solution is an architecture for organizing projects inside Visual Studio. One solution can have multiple projects, and in them we can consume each other as well. Below the solution file, we have the project file. The project file in our example is codepulse.api. Similar to a solution, a project is a structure for organizing files and folders in a single project. If you double click the project file, you will open the project.csproj file. Inside this, we can see the properties of the project from our example. We can see that we are using .NET version 7 as our target framework. We have enabled nullable and we have enabled implicit usings, and these are the properties for this project. When you use Nuget packages and add them in your application, they will also end up as a reference to this project file. Now let's have a look at the launch settings.json file, which is under the properties folder over here. As the name suggests, this launch settings.json file has launch related configuration. In here, you can see the profiles that have been set up for our project. And these profiles also match to this drop down over here. So we have HTTP, HTTPS, IIS Express, and other ones. So we have HTTP. For example, if we want to run over HTTP, we have the application URL configured to this profile. And also we have HTTPS, in which we have the application URL configured to HTTPS. Make a note of the URLs that your application is using. This will be different to the ones that I'm showing here on the screen. So when we run the HTTPS profile, which is selected by default, it will run over https://localhost:7226, which is the port number, and that's the URL for the API. So the API will run under this URL when it's running under the HTTPS one. Now this URL will be totally different to yours. So whenever I use my API URL, you have to use your API URL. Then we have the controllers folder over here. Inside this folder, we have different endpoints or controllers for our application. We will look at controllers in a later video, as we will be using controllers a lot throughout this course. We will be creating more controllers or endpoints for our application. After that, we have the app settings.json file. This file is used to store configurations for our application. Stuff like the database connection strings, environment specific variables resides in the app settings.json file. Finally, we have the program.cs file, which is a very important file inside a .NET Core project. The program.cs file is the entry point of the application. The code inside this file is executed first when the application runs. In this file, we add dependencies to our application, which can be used later on in our application. Dependency injection is an important concept, and ASP.NET Core gives us dependency injection by default. We first add services to the container, and .NET supports the dependency injection software design pattern, which is a technique for achieving inversion of control between classes and their dependencies. Another important function of the program.cs file is to configure the HTTP request pipeline. By using the request pipeline, we add middleware, which is a software that is assembled into the application pipeline to handle requests and responses. These are the middlewares that have been configured in our application by default. The order in which they occur is also very important. Now that we have looked at the files and folders for our .NET API, let's come back in the next lecture and understand our domain and what we are trying to build. As we are about to build a RESTful web API using ASP.NET Core, let's first understand what is REST. REST, or Representational State Transfer, is a style of architecture for building web services. REST is a set of principles that define how web services should be designed and interact with each other. At its core, REST is based on the concept of resources. A resource is anything that can be identified and manipulated through a web service. In a RESTful architecture, resources are accessed through URLs. Each URI identifies a specific resource, and HTTP verbs are used to perform actions on these resources. For example, a GET request can be used to retrieve a resource, while a POST request can be used to create a new resource. REST also emphasizes a stateless client-server model. This means that the server should not store any client state between these requests, and the client should provide all necessary information with each and every request. This allows for scalability and readability in the system, as the server can handle multiple requests simultaneously without needing to maintain client state. ASP.NET Core provides a powerful and flexible platform for building RESTful APIs. With its support for HTTP verbs, routing, model binding, and response types, ASP.NET Core makes it easy to implement RESTful APIs that are both scalable and maintainable. Let's also understand HTTP verbs. HTTP verbs define the type of actions that can be performed on a resource identified by a URI. Some common examples of HTTP verbs are GET, POST, PUT, DELETE, PATCH, and options. Out of these, the most common ones are GET, POST, PUT, and DELETE, and these are the ones that we are going to later implement in our web API. Let's see some common use cases of these HTTP verbs and how they identify actions on these different URIs. If you see the first highlighted action, which is pointing to yourapi.com/API/employees, this URI will be used along with the HTTP GET keyword to get the list of all employees. This is the URL convention that we use when we have to get a resource. If you look at the second row, we are reusing some of the bits from the first row. So we are pointing to yourapi.com/API/employees, which gives you the list of all the employees, but then you want to get a single employee by its unique identifier, and hence you are passing the identifier after the employees. So clearly, GET can be used in two different ways. One, to get all the employees, and two, to get a single employee by their unique identifier. Then we also have the POST HTTP verb. The URL for the POST HTTP verb is similar to the first one, which is the get all employees. So in this URI, the URI is also pointing to the employees resource, which is yourapi.com/API/employees. Now, because this is an POST HTTP verb, it means that we are using this to create a new resource, in this case, creating a new employee. After that, we have the PUT HTTP verb, which is used to update a resource. So similar to the GET, we first have to use a URI that uniquely identifies a single employee or a single resource. then we will use the HTTP put keyword to treat this as an update action. And finally, the most common HTTP verb that is used is delete as well. So in the delete, the convention of the URL is similar. So it's going to a single resource or a single employee, and we are using the HTTP delete verb so that we can identify this action as a delete action. In this lecture, let's have a look at routing and how it's done. In ASP.NET Core Web APIs, routing is the process of matching incoming HTTP requests to the appropriate action methods that will handle those requests. Routing is used to map the URL of a request to a controller and then its action method. If you look at the example on the screen, a user is trying to request to delete a product. The user is entering the URL localhost 1234 /API /products / the ID of the product that the user is want to delete. Now, if you see, the application is handling this URL and is matching the resource that is products to the controller products. So we have a controller in our application called products, and the resource from the URL is matching the resource of the controllers. So that's the first level match. After that, we have a delete method inside the controller. That's our delete action method. And it has the attribute HTTP delete, which stands for the delete verb that the user is providing along with the URL. Now, after the products resource, you also see a number, and that is number 2. And that means the user is trying to delete a product with the ID of 2. And if you look at the delete method on the right hand side, it takes a ID as an input parameter. And if you look at the attribute, the HTTP delete attribute also takes an ID. The ASP.NET Core application is able to get the ID from the URL and able to pass it as an input parameter to the method. Once the code has the ID for the product and it knows that this is the delete method, it will go on and delete the product from the database. And this is how routing works in an ASP.NET Core Web API. Now that we have covered our basics, it's now time to dive deep and create a full real-world web API. We will be building a web API that manages a technical coding blog. This is how our domain model will look like. It comprises of these two important domain models. One is the category and one is the blog post. If you imagine a technical blog, or in that case any blog post, it comprises of blogs. So the author of that blog will create many blog posts, and this is what we have on the right hand side over here. The blog post will have an identifier to uniquely identify the blog post. It will have a title, which will be the heading of the blog post. Then we'll have a short description, which will be used to just briefly describe the blog post and what it is about. Then we will have the content, which will have the entire content of the blog post. So it will have the subheadings and the paragraphs and further images that describes the content. And we will write our content as Markdown. After that, we will have the URL handle for the blog post. And this is, for example, if you have codepulse.com, then the URL that follows the codepulse.com that takes you directly to the blog post will be the URL handle. Some also call it the slug. Then we will also have a featured image of that blog post, and we will be putting the URL of that featured image inside this blog post. So whenever we want to display this blog post, we will first introduce the featured image and then the heading and the content and further on. The blog post will also have a date created, which will be a date time. and an author information, so who wrote this blog post, and whether this is visible to the public or not, so a Boolean flag that covers that. The second important domain model in our application will be the category, and that's on the left hand side over here. It looks to be quite simple. Category only has 3 fields. One is the unique identifier, which is a GUID. The second one is the name of the category. For example, for a coding blog, we can have HTML as a category, CSS as a category, or ASP.NET as a category, and so on. We'll also have the URL handle that it takes us to that particular category on the website. If we talk about the relationship between the category and the blog post, we will have a many-to-many relationship. That means one category can have many blog posts. For example, if it's an HTML category, you will have multiple blog posts that relate to the HTML category. And similarly, we will have one blog post that can have many categories. For example, if you are working on a login page and that's an HTML and CSS category, so you will add HTML and CSS categories to that particular blog post. That makes this a many-to-many relationship. So now that we know what we are trying to build in our web API and in our Angular project, let's come back in the next lecture and create the domain models inside our ASP.NET Core Web API. In the last lecture, we discussed the domain models that will be part of our application. And in this lecture, we will create the domain models for our ASP.NET Core Web API. For that, let's come back to Visual Studio and create a folder for models. So I will right click on the project over here, go to add and create a new folder. Let's name this models. Inside the models folder, I will create another folder that will represent the domain models. So inside models, I will create a folder. So right click, add, and create a new folder called domain. So any class files that will go inside the domain folder will represent the domain models. And we have 2 domain models to create. One is the category, one is the blog post. So let's create the blog post first. So right click on domain, add a new class, and let's rename that to blog post .cs and click on the add button. This blog post domain model will have a few properties as we saw in the previous video. So let's create these properties, and the short form for a property is prop and double tab. Otherwise, you can write public and the property type, the property name, and their getters and setters. So that's the definition of a property, and you can use the shortcut prop double tab. So the first property we want to create is the ID, and that is of type GUID. So let's create a GUID type. The name is ID, that's the unique identifier. After that, we want the title. So prop, again, string, and it's called the title. We will have the short description, so that is another string, and that is short description. Then we will have another property of type string, which will hold the content of this blog post. So the name is content. And I'm just copying the previous property and pasting it, and to speed up the process over here. After the content, we have a featured image URL. So featured image URL, and that will hold the URL of this blog post that features right on the top. After that, we have the URL handle or the slug, but we'll call it the URL handle. Then we have a date time property. So I'll change the string to the date time, and that will be the published date. After that, we have the author. So that is of type string, and that is the author property, which will have the name of the person who's writing this blog. The final property we will have is a Boolean type, and that will be a isVisible property. And that will mean that is this blog visible to the public or not. So we have 9 properties for the blog post. You can pause the video over here and write these properties for your domain model. Moving on, we want to create the second domain model, which is the category domain model. To create the category domain model, we'll follow the same steps. So right click on the domain folder, add a new class, and rename that to category.cs. Click on the add button to create this domain model. And we will have a few properties for the category domain model as well. The first one is the ID. So that is of type GUID and the name is ID. The second is a name property. So the name of the category, that is of type string. After that, we have the URL handle for this category. So it will be of type string and the name of the property will be URL handle. Now that we have created the domain models for our application, in the next lecture, we'll come back and install the necessary Nuget packages required to install and use Entity Framework Core. In the last lecture, we created the domain models needed for our blog application. In this one, we are going to install the Nuget packages needed for Entity Framework Core. And we would need Entity Framework Core because we are following a code first technique to create the database that is needed for our application. And because we have the domain models will basically drive the structure of the database. So we will tell Entity Framework Core that these are our tables, and Entity Framework Core will create the database for us. So for that, we first have to install the packages for Entity Framework Core. To do that, I will right click on dependencies, come to manage Nuget packages. It will open up a window. Let's go to the browse tab over here, and we have to search and install 2 packages. The first one is Microsoft.entityframeworkcore.SQL Server. So type that and paste it here in the browse section. This is the first package over here. So I will click and install. Once this package is installed, I will go on and search for the second package, which is Microsoft.entityframeworkcore.tools. So I will copy that, paste it in the browse section, search for that package, and click to install this Nuget package. So now that we have installed the packages needed for Entity Framework Core, we'll come back in the next lecture and create a DbContext class. In this lecture, we will understand and create a DbContext class. In ASP.NET Core, a DbContext class is a class that represents a session with a database and provides a set of APIs for performing database operations. This is part of the Entity Framework Core packages. The DbContext class is responsible for maintaining a connection to the database, tracking changes to data, and performing database operations such as squaring, inserting, updating, and deleting. It also provides a way to define the database schema using entity classes or domain classes that we just built, which maps directly to database tables. So we can say that the DbContext class is a bridge between your domain model classes and the database. DbContext class is the primary class that is responsible for interacting with the database and performing CRUD operations on our database tables. In the image, you can see that whenever a call comes to a controller, in order to get or retrieve a data, the controller will have to talk to the DbContext, and it is the responsibility of the DbContext to get the data from the database and provide it back to the controller. So now that we know what the role of DbContext is, Let's come back to our application and create a new DbContext. To create the DbContext class, I will first create a folder for the DbContext class. So right click on the project, go to add, new folder, and we will call this data. So the DbContext class will reside in this data folder. So right click on the data folder, add, and we will add a new class. And we will rename this to application DbContext. .cs. So our DbContext class name is application DbContext. This class basically derives from DbContext class, which is coming from the packages that we installed. So this inherits from DbContext. Press Ctrl dot to pull in the necessary using statements. So this is coming from Microsoft.Entity Framework Core package. So make sure that is there. Now we would need a constructor for this class, and an easy way to generate a constructor is by clicking on this class, press Ctrl dot again, and let Visual Studio suggest you some constructors. It says over here, generate a constructor of type this, or generate a constructor with the options parameter, which is the DbContext options. So we will select this one, and it creates a constructor for this class, which takes the DbContext options and then passes it to the base class. This will be helpful when we configure our DbContext from the program.cs file, and we will pass the connection information through the DbContext options later on. Now that we have the constructor in place, we would want DbContext or the collection classes as properties to this DbContext class. So let's create the properties after the constructor, but within the class. So to create a property, I'll write prop double tab, and this property will be of type dbSet. And dbSet further takes a type, and the type of this dbSet property will be the domain models. We have the blog post and the category. So the first dbSet collection will be blog post, and this comes from the domain model folder. Let's rename that to blog post within S. So that becomes blog posts, and we would need another property of dbSet collection, and that will be for the category. And we will call this categories. So basically, dbSet class represents the collection of entities from a particular type. In our case, it's blog post and category in a relational database. It is the part of the Entity Framework Core's ORM capabilities and provides a way to interact with the entities in the database. So we will later on use these properties to interact from our application to the database tables, which will be of this name, and the type of columns and properties are taken from the domain model properties over here. So by that, we have created the DbContext class. In the next lecture, let's come back to add the connection of our database inside the app settings.json file. In this lecture, we will create a new connection string that points to a SQL Server database, and we will use this connection string to provide it to Entity Framework Core through our DbContext class, and that will be used by Entity Framework Core to make connections to the database from our application. So let's come back to Visual Studio, and we create connection strings inside the app settings.json file. So let's open app settings.json. And after we have the allowed hosts, we will put a comma and create a new object called connection strings. And this object can have multiple connection strings, but we want to first create a connection string for our application, which will store the categories and the blog posts for our application. So let's give a key value pair. So the key is the name of the connection string. So let's call it code pulse connection string, and then we have to give a value to this connection, and the value is basically comprising of the server information and the database information and and any additional information like the username or password if there's any. So first of all, we have to give the server information. So inside the string, we will say server is equal to, and here we have to provide the name of the SQL server that we installed in the section 1. So if you have not done that, please go back and watch the video and install a local instance of SQL Server and also SQL Server Management Studio, by which you can actually go into the server and see the database and the tables. If you have followed the videos in section 1, we actually installed a SQL server. So I'm trying to connect to that SQL server, and in my case the name of the server was localhost /ms SQL Server 01. The name of your SQL server would be or could be totally different, so make sure you follow what you created back in section 1 videos and then come here. So I will copy the server name from here and I will check that I'm able to connect to this by clicking on the connect button. So I can connect to this, and if I expand on databases, I do have a few databases as well, but I don't have the Code Pulse database, so I will create that soon. So with that, I will copy the server name, come back to the connection string and paste it over here. So this is the server information. Then comes the database information. So I'll put a semicolon and I want to tell the application what database do we want to create for this application. So I will say database is equal to, and this will be the name of the database that you want to provide, because there is no database at the moment and we are following the code first approach in Entity Framework Core. We want to provide a new database name. So I will call my database Code Pulse DB. And after providing the server and database name, we are using Windows authentication, so we don't have to give a username or a password for now, but we want to specify the trusted connections. So we'll say trust server certificate is equal to true, and so a semicolon again, and I'll move this to the right, and trusted underscore connection is equal to true as well. So we have these 4 details: the server name, the database, trust server certificate is equal to true, and trusted connection is equal to true as well. So with that, we have the connection string ready. In the next lecture, we'll come back and inject the DbContext class that we created and provide the connection string to the DbContext class. In this lecture, let's get to know dependency injection and then inject our DbContext class. Dependency injection is a design pattern used to increase the maintainability and testability of applications by reducing the coupling between components. In ASP.NET Core applications, DI is an essential part of the framework and is used to manage the lifetime and dependencies of services used throughout the application. At its core, DI works on this fundamental that instead of instantiating objects within a class, those objects are passed in as parameters to the class, like passing it to the constructor or the method instead. This allows for greater flexibility in the way objects are created and managed, as well as easier testing of individual components. Dependency injection in ASP.NET Core is really simple. ASP.NET Core provides a built-in DI container that can be used to manage the dependencies of an application. The DI container is responsible for creating and managing instances of services which are registered with the container when the application starts. Let's look at an example of an application which doesn't use dependency injection. We have a controller class and we have a constructor over here, which is controller. Inside the constructor, because we want to use the service myService class later on in the index action method over here, we are instantiating the class inside the controller over here. Now this class would have to be managed by the controller, and later on, if the class name changes or we have to implement a different implementation of my service, then we have to change all the controllers or classes that uses this my service. Instead of creating the instance within the class, this is what dependency injection does. We can easily inject the interface my service inside our application in the program.cs file, and we also provide the implementation detail of the interface of what we are trying to implement. So my service has been injected inside the application. Inside the controller or any controller that want to use this my service, we can easily inject the service as a parameter to the controller or a parameter to the method. And then we can use this service throughout the application, for example, in this index action method. This is a good practice and it also satisfies the D in solid. By doing that, we can easily change the implementation of my service to say my service 2, which is another implementation, and we can easily change the implementation in the program.cs file just at one place, and then later on all the controllers can easily implement the new implementation, which is now provided and managed by the application. So let's come back to our application and create or inject the DbContext class that we created inside the data folder and inject it inside our application so that we can later on use the DbContext class inside controllers or repositories. So let's inject this inside the program.cs file. And on the top over here, we have the services that are injected inside the application before we actually build it. So before we build it, we want to inject the DbContext class as well. And the way we do it is by using the services collection in the builder. So builder.services.add DbContext, and DbContext class takes a type. And the type of DbContext class is the application DbContext. So I will write application DbContext, and this comes from the data folder. So make sure you have this using statement at the top. And now in round brackets, we have to provide the DbContext options using the builder. So I'll say options such that, and I will open and close curly braces and finish the semicolon over here. So now we have to give the options or the DbContext options using this builder. So I will say options dot use SQL server, because I'm using a SQL server. So I'm telling Entity Framework Core to use a SQL server as a connection. So I will click on this method, and this method comes from using Microsoft.Entity Framework Core package. And this method will basically need a connection string as a string type. And we have the connection string because we defined it in the previous lecture in the app settings.json, which is over here. So we just have to bring this connection string inside the program.cs file. And to do that, we can again utilize the builder over here. So we'll say builder.configuration.get connection string method, and this would take a name of the connection string as a string. So the name of the connection string is code pulse connection string. Yours could be totally different, so make sure you are copying the correct name from the app settings.json file. So I'll do that and paste it over here, and then put a semicolon to finish the sentence. So to recap, we are injecting the DbContext, which is of type application DbContext, inside the program.cs file, which is the application itself, so that we can later on use the application DbContext to communicate with the database from the controller or the repositories. In the last few lectures, we have done all the groundwork to set up Entity Framework Core, and we have created the DbContext class and injected it inside the application. Now we will run Entity Framework Core migrations, and what this does is it will create a database with the name that we provided inside the the connection string, and it will create a database inside a SQL server because we have provided a SQL server, and then that database will be used and configured with our application, and later on when we create a controller, we will perform CRUD operations on this database that we have created. So let's come back to our application. To run Entity Framework Core migrations, we have to go to Tools and come down to Nuget Package Manager and click on Package Manager Console. In here, we have to write two commands. The first one is add-migration, followed by the name of the migration in strings. So let's write this command first. So add-migration followed by the name of the migration. Because we are creating a new database, the new tables and columns for the first time, we can write initial migration. After that, press enter. And what this is doing is it is creating a script in terms of a C# world. It is creating a script that Entity Framework Core can use to create later on a SQL script and then create a database. So now it has created a new migration file, and that resides in the migrations folder that has been created by Entity Framework Core. And this is the first migration, as you can see, the initial migration, and it has all the code that is needed to create the two tables that we have. One is the blog posts table and the other one is the categories table, and it has all the column information in it as well. So when we run the next command, that is update database, Entity Framework Core will read this file and have a connection with the SQL server that we mentioned inside the app settings. And if a database does not exist, it will create one. So let's come back to Package Manager Console and write the second command, that is update-database, and press enter to run this script. So the script has ran successfully. Now to confirm, we can open SQL Server Management Studio. So I'm already in the SQL Server that has been mentioned in the connection string. Now if I expand on databases, we did not have a code pulse DB before, but if I refresh this server again and expand on databases, we should now have the code pulse DB. If I expand on the DB, we have the two tables necessary for our domain to work, which is the categories table having the 3 columns, ID, name, and URL handle, and the blog post table, which has the 9 properties or columns that we defined inside the domain model. So all this information is getting picked up from the DbContext because we provided the collections of the table in terms of the type, blog post, and category over here. So we can say that the DbContext class always works with the domain model folders, and later on we will have DTOs and other class files, but the DbContext class always works with the domain model folders. In the last few lectures, we have set up Entity Framework Core and we have created a new database that our application can talk to. Now it is time to create a new controller or an endpoint, and also the actions, that is the CRUD operations like get, post, put, and delete inside our controllers. Let's come back to our application, and we want to first perform CRUD operations on the category domain model. So category is a simple domain model, and we'll use that to perform CRUD operations like create, read, update, and delete on the category domain model. So we want an endpoint that performs CRUD operations on the category domain model. So for that, we will create a new controller, because the weather forecast controller that is there by default is only a default scaffolded code. We won't be using that. If you want, you can delete this file and this file, but for sample purposes, we'll just keep it there. I will create a new controller by right-clicking on the controllers folder, go to add, and click on this controller file. Because this is an API, I will select the API from the left hand side and click on the API controller empty template and then click on add. It will then ask for a name of the controller, and all the controllers has to, and that is a rule, that they have to be appended with the controller keyword, because the application then searches for all the class files with the controller keyword. So the name of our controller will be the categories controller. So we have the name as categories controller.cs. Click on the add button, and this will create a controller over here. And this categories controller inherits from the controller base class. And you can see over here that it has two attributes. One is the route that goes to API/controller name, which is categories. And it also has the API controller, which gives it other useful benefits. If we want to reach this controller, the endpoint that we have to go to is https localhost the port number, which can be anything. So I'll just say xxxx/API/categories. And this is the path needed to come to this controller, and other actions will have their own path as well. Now that we have the categories controller ready, we will create the CRUD operations like get, post, put, and delete in this controller. And we will first start with the post operation, which is the post HTTP verb, to create a new category. And that is in the next few lectures. In this lecture, we will understand more about DTOs and domain models. Before we proceed ahead with any other action methods, it's now time to understand what DTOs are and how they differ from domain models. DTOs, or data transfer objects, are objects that are used to transfer data between different layers of components of an application. They are simple objects that typically contain a subset of the properties of a domain object or entity, and are designed to be used for a specific purpose, such as transferring data over the network or between layers of an application. As we see in this example, we have our API over here. We have the database which talks to the API, and we also have the client which is calling this API to get some data or to add some data. Now at the moment we have domain models over here. And for us, because we are using Entity Framework Core, domain models have a mapping between the tables in the database and the domain models that are used internally in the application. When you use Entity Framework to talk to a table, it gives us the domain model, because the DbContext class only knows about the domain models. But because we have the domain models within the API, it is a good practice to add a layer of DTOs, that is the data transfer objects, and that is what we send back to the client. So we never send the domain model back to the client, but we send the DTO instead. So once the DbContext class is able to provide us with the list of domain model or the information about the domain model, we then do a mapping between the domain model and the DTO so that we can send the DTO back to the client. If it is information coming from the client, for example, if the client wants to add a new resource, then we receive a DTO, which then we convert from DTO to domain model, and then we send the domain model using Entity Framework Core to the database. So that's how DTOs are used in the application, and that's how they differ from domain models. Now you would be asking, what are the benefits of using DTOs if they are exactly the same as domain models? Now the first thing is, domain models can have slightly more properties and slightly different named properties, which we don't want to expose to our client. So there are actually advantages of having DTOs, because when we can manipulate our properties inside the DTOs that we want to send back to the client. For example, the advantages of DTOs are the separation of concern. So DTOs help us to separate the concerns of an application. The domain objects are usually tightly coupled with a database schema, as we just know, because Entity Framework Core uses them to talk to a database, whereas DTOs can be designed to match the business requirements. This separation ensures that the domain objects are not tightly coupled with the API or the view layer. The second advantage is performance. Using DTOs, you can help to improve the performance of an application. This is because they allow us to retrieve only the data that is needed. For example, in our application, if we don't want to send the whole region information back, we can just send in the name of the region back if that is the requirement, and we don't have to send other properties of that region domain model back to the client. So then in that case, we just use a DTO and only one property in that DTO. Then we map all the information from the domain model to the DTO that we can send back to the client. It also improves on security because DTOs can help us to improve security by limiting the amount of data that is exposed to the client. By only exposing the necessary data, you can reduce the risk of exposing sensitive data to unauthorized users. And at last, it also helps us to improve versioning because it can be versioned independently, allowing you to update the API without breaking the existing clients. If you were to make a change to a domain model which was exposed to the client, it wasn't possible because then the client wouldn't be able to send the information again because you now have breaking changes. But now we can change the domain model but can keep the DTO the same so that we are not breaking the contract between the client and the API, but we can still play around with the domain models within our application. Let's create our first action method, and that will be the post action method to create a new category in the database. So for that, we will first put a comment defining the routing to this action method. So we have the base route that is to the controller, but after that, what is required to reach to this new action method, and we will put that information over here. But otherwise, we will have a HTTP post keyword or attribute on this method, and we will define this method as public async task of type iAction result, and we will give the name of the action method, and because we are creating a new category, we can define it as create category method. Now this create category method needs some information as parameters because it needs the user's input that what category this API should create on their behalf. For that, we will create a DTO object. As we saw in the previous lecture how DTOs differ from domain models, we can never and we should never expose our domain models because that's the business logic, but DTOs, which are data transfer objects, can be used to expose to the outside world. So we will create a new folder under models. So right click on the models folder, add a new folder, and we will call that DTO. So that will be the DTO folder or the DTO models. In here, we will create our first DTO class. So right click, add a new class, and I will call this the create category request DTO.cs. So that's our create category request DTO. And this will have the properties needed to create a category by the API. So if we look at the category domain model, we have ID, name, and URL handle. But we don't want the user to pass us the ID. This is a unique identifier and should only be created by the application, that is the API. So the only information that is needed is name and URL handle. So I will copy these two properties and come back and paste it inside the request DTO. You can also write it yourself or have different names to this request DTO. Back inside the controller, we will use this request DTO as the input parameters to this method. So we will say create category request DTO and press control dot to get this from the DTO models folder. Give it a name. Let's give it request. And this is what the user is sending us. And later on, because we are building an Angular application, the Angular UI application will send us this request DTO, and then the API will take this and transform this into a domain model to then submit this to the database. So the first step of this method is to convert this DTO to a domain model. So map DTO to domain model. And the domain model we have is category. So we'll say a variable category is equal to new category, and this comes from the domain model. And inside that we have two properties to fill. One is the name, which is coming from request.name. And the second thing is the URL handle, which also comes from request.URL handle. So these are the only two properties. We are not giving the ID property because Entity Framework Core is smart enough to create a unique identifier when it actually saves it to the database. So you can ideally skip the ID over here and Entity Framework Core will do the job for you. After we have the domain model with us, we now want to use the injected DbContext class in the controller, so we can use the DbContext class and provide this new category so that Entity Framework Core can save it for us. So the way we can use the injected services is by injecting it inside the controller and inside the constructor. So let's create a constructor. So CTOR to create a constructor, and then inject the DbContext class that we injected inside the application and inject it over here so that we get an instance of the DbContext class. So our DbContext class is called application DbContext. So let's inject that. So application DbContext and call it a name. Let's call it DbContext. Press control dot to create and assign this private field so that we can use this private field now inside the methods over here inside the controller. So now the application will give us an instance of the application DbContext class. So we don't have to say new application DbContext class, and we don't have to new it up and manage the instances. The application is doing it for us. So let's use the DbContext class and let's say await DbContext class dot add dot categories, because that's the categories collection. So categories dot add async method, and then pass the category that we want to create over here inside this method. So this line will basically provide the category to the collections that we have inside the DbContext class. But when the application runs, this line alone will not create the new category inside the database, because we have to tell the DbContext class to save the changes. So we will have another line and say await DbContext class dot save changes async. And with that line, the Entity Framework Core will actually save the changes inside the database. After this has been saved, we want to return the result. So we want to return something like an OK response, which is a HTTP 200 response. If I hover over it, it is a success status response. So we'll say OK and also pass the return result with it. So the return result, you would be enticed to use the category domain model, but as we discussed, we never expose the domain models. So we'll have to map this back from the domain model to a DTO, and for that we can create a new DTO and we can call it the category DTO. So let's say right click on DTO folder, add a new class, and let's call it category DTO.cs. And category DTO will have all the information required to the user, that is the Angular application, and that will be the three properties that we have: the ID, name, and the URL handle. So we have this. I'll paste that in the category DTO model, and now I can say variable response is equal to new category DTO, and inside that we'll have three properties. So the ID is now fulfilled or populated by the entity framework core. So I can actually say category.id, then name is equal to category.name, and then URL handle is equal to category.URL handle. So now we can return the DTO object back. So I'll say OK response and give the response back to the caller. That will be the Angular application later on. So with these changes, it is now time to test our application. So I will run the application using this run button over here. When we run the web API, it presents us with the Swagger UI screen, and Swagger is basically a client from which you can see the documentation of the API that you have, and also a tool from which you can trigger these endpoints. So we have two endpoints, the categories and the weather forecast, which was given to us by default. So we can skip that. But this is the new endpoint, which is the categories controller. And inside this controller, we only have one action method as of now. So let's expand on this post action method and click on try it out. It needs the two properties, which is the name and the URL handle. And then we will use this execute button to create this. So let's put a breakpoint back inside our code. So we have this action method, which is the post action method. So let's put a breakpoint over here and come back to Swagger and create a new category. So I'll give the name as HTML, and let's give the URL handle as HTML-blogs, because that's what a URL should look like. So with that, I will click on the execute button. This takes me to the debugging point that I have inside the controller, and let's go line by line. So it's first creating the DTO object or the domain model object from the DTO that we have. So we are getting the information back inside the request. The second thing is entity framework is basically adding this category to the categories collection. So if I execute this step, it still has not created the category, and I can confirm that by going to the table and selecting on the categories table. So select star. So you can see we don't have anything here as of now, but as when I click on or execute this line, which is the save changes async, and if I go to the table and execute this again, we can now see the HTML category over there with the ID generated as well. And finally, we are mapping this back and returning the response. So I can click on the continue button, and Swagger will now display me the response over here, which is the success response. So if I execute this again with a different one, so let's say CSS blogs, click on execute, and let it continue. We can now see the response body, which is a success response because it is the HTTP code is 200, and we have the name, URL handle, and the ID information as well. So by this, we can say that we have successfully created our first action method, that is to create a category. In this lecture, let's understand what repository pattern is. Repository pattern in ASP.NET Core is a design pattern that helps to separate the data access layer from the rest of the application. It provides a standard interface which is an interface class for accessing and managing data in a data store, such as a database, without exposing the underlying implementation detail to the rest of the application. Repository pattern typically involves creating an abstraction layer between the application and the data store, which is implemented by a concrete repository class. The repository class is responsible for performing CRUD operations, that is create, read, update, and delete, on the data store, and it exposes a set of methods that the application can use to interact with the data. If you remember your application now, we have the DbContext class injected inside the controller, and it is the controller who is directly talking to the database using that DbContext. That is also a wrong practice, and using the repository design pattern, we can eliminate that by adding an abstraction layer in between. Repositories can be added in between the controller and the database so that all the operations on the database is then handled by the repository. The DbContext class is injected inside the repository rather than inside the controller, and it is the repository that then injects in the controller. So the controller will use the repository instead of using the DbContext. By doing that, the controller now has no awareness of what's being called through the DbContext. Whether it's a SQL Server database or a MongoDB database, it has no idea about it. Controller is just using the interface method exposed by the interface repository, and the implementation is hidden behind the implementation repository. Using that, you can switch the logic and the data stores behind the implementation repository. For example, you can use Entity Framework Core to store your changes in a database, or you can just use an in-memory database by creating another implementation repository. All of those changes are happening behind the repository, and the controller has no knowledge about the data stores at all. By using repository pattern in ASP.NET Core, we developers can achieve several benefits. That is, decoupling the data access layer from the rest of the application, which makes it easier to maintain and test the application. Providing a standard interface for accessing data, which improves the consistency and readability of the code. Now, every connection to the database goes through the repository. We can also improve the performance of the application by using caching, batching, or other optimization techniques. Supporting multiple data sources, which allows the application to switch between different data sources without affecting the application logic. Overall, the repository pattern is a powerful tool for managing data in ASP.NET Core applications, and we will introduce repositories in our application as well. In the last lecture, we saw how repository pattern can be a great benefit to our application. So now we want to implement a repository pattern inside our application. So for that, I will first create a folder in which I will create the interfaces and implementations for these repositories. So right click on the project, go to add, new folder, and let's call this repositories. In the repositories folder, let's create two more folders, one for the interface and one for the implementation. So right click on the repositories folder, add a new folder and call this the interface. And another one for the implementation. So first, let's create an interface for the category repository. So I will right click on the interface, add a new class. And because this is an interface, I will select the interface from here and then rename this to I category repository.cs. Click on add. And this is an interface, a public interface I category repository. In here, we can only define the definition of a method and not an actual implementation. So let's create the definition for the create category method. So that will be a task of type category, and that will be the return type. The name of the method will be create async, and it only takes one parameter, that is the domain model. So we'll take the category domain model and give it a name. Repositories should only deal with the domain models, so any conversion or mapping that has to be done between DTOs has to be done inside the controller or the services if there's any. So now we have created a definition, and it will basically take a category and insert it in the database and then return the created category. So now we have the interface. Let's create the implementation class. For that, right click on the implementation folder, add a new class, and rename this to category repository.cs. And this class basically inherits from the iCategory repository interface, and because this interface has one method definition, this implementation class has to have those methods, and let's create those methods. So I can easily click on this interface, press Ctrl dot and say implement interface. So now the class is implementing this interface method, but we have to just change this internal definition. Because we are taking away the functionality of the DbContext class from the controller, so because we were doing the DbContext and saving the data over here inside the controller, that is a bad practice. So let's remove this functionality from the controller and add it to the repository instead. For that, we would have to inject the DbContext class inside the constructor to this class. So let's create a constructor to this repository. CTOR double tab to create a constructor, and then inject the application DbContext. So application DbContext class, give it a name. So I'll call this the DbContext, and press Ctrl dot to create and assign this private read-only field. Now this private read-only field can be used inside this create async method over here. And we basically want to do the same thing as we are doing in the controller, but now we'll take this away from the controller. So I'll do a Ctrl X and paste it inside over here. Because we want to have this as an asynchronous function, we'll say public async task of type category, and that fixes the red squigglies. Finally, because this method expects a return of type category, we have the category created already, so we can just return the category domain model from here. As you can see in this repository, we are only dealing with the domain models and not the DTOs at all, and we will never deal with DTOs inside the repositories. So I have this method now. To be able to use this repository, I have to inject this again using dependency injection in the application so that I can then use it inside the controller. So I will first go to program.cs file, and before we build the application, I can come over here and say builder.services.add scoped, and add scoped needs a type of an interface. So category repository, comma, and it needs an implementation class, so that is the category repository. And then open and close the round brackets, and this is how you inject a service inside the program.cs file. It reads as that if I want to inject, or if I want to get an implementation class, please provide me the implementation class coming from this class. And that's how I can use it inside the controller. So now that we have injected it, I can come back to the controller, and I am no longer using the DbContext class inside the controller. So I can get rid of this, and this line. Instead, I want to use the repository, because now repository is doing the heavy lifting of saving the changes to the database. So any communication with the database has to be done through the repository. So I will inject the iCategory repository interface, give it a name, and then press Ctrl dot and create and assign this field. So I have a create repository interface implementation instance. So after I map it, I can say await category repository dot create async method, because that is the only method that exists in that implementation at the moment, and then pass the category to it. And with that line, we are basically abstracting the implementation to the repository, and the controller has no idea how the repository is able to talk and save these changes inside the database. Whether it's at Entity Framework Core or just ADO.NET, it doesn't care. The controllers is basically giving that functionality to the repository to do its job. And by this, we have changed the functionality by not using the DbContext class directly in the controller, but by using the repository in the controller. So if we now run this application, it should behave exactly the same as it was before this change. But now we have just made it better by using repository pattern. So Swagger is running. I expand on the action method that we have, click on try it out, and create a new category. So let's create the ASP.NET category. So ASP.NET Core, and the URL handle will be ASP.NET Blogs. So with that, I'll click on execute and wait for a response back from the API. So we got a 200 success response back, and we have the URL handle, name, and identifier. And if we check the categories table, we should now have 3 categories in here. So we can say that we have successfully created the create category action method, and it's using the best practices such as asynchronous programming and repository pattern as well. In this lecture, we will create a new Angular application from scratch using Angular CLI. If you have not followed the installation videos in section 1, I would suggest you to go back and watch the development setup videos. For Angular, we would need Node and the Angular CLI installed before we can proceed ahead. We are going to create our Angular application inside this UI folder. This is the folder which we created in the previous section and is empty at the moment. So make sure you navigate to this folder before you do anything else. In here, you can open your terminal or your command prompt window or a PowerShell window pointing to this location. I am in Windows, so I can press Shift and right click over here to open a PowerShell window. So this will basically is pointing to eDrive Udemy Code Pulse, the UI folder in which I want to actually create my Angular application, and I have Node and Angular CLI installed. So with that, I will write the command ng new and then the project name. So I'll write the command ng new and then the name of the project, which is Code Pulse, and with that press enter. Now Angular CLI will ask you a few questions before it actually creates the project for you. The first question Angular CLI asks us is, would you like to add Angular routing? And it says yes or no, and here we will type Y for yes, and we want Angular routing. The next question it asks is, which style sheet format would you like to use? In our case, in our application, we would like to use CSS, but you can use the arrow keys if you want something else. But for our case, we will use CSS and press enter over here as well. Now it is installing the npm packages needed for Angular to perform or run, and it will take a few seconds for Angular CLI to create this project for us. So it took Angular a minute or two to create all the files necessary for our application, and it has created a folder over here, and the folder has the Angular application. So coming back to our our PowerShell or the command prompt window or the terminal window, we will navigate to this folder which it created, and that is inside the UI folder. So I will say cd code pulse and navigate inside the folder, and in here I will open my Visual Studio Code, and a shortcut for that is code space dot, and that opens the folder which is over here. So now we have Visual Studio Code, and Visual Studio Code has opened the Code Pulse folder for us. In the next lecture, let's come back to see all the files and folders structure that has been created by Angular CLI and understand our project a little bit more. In this lecture, we will look at the files and folders that were created as part of the Angular scaffolding when Angular CLI created the Angular application for us. So let's come back to Visual Studio Code, and Visual Studio Code is the editor that I will be using to develop the Angular application, whereas I will do all the coding for the API which is in .NET in Visual Studio. So you can see, or you can make out the change of interface. So the Solution Explorer in Visual Studio was on the right hand side, and the kind of the Explorer of Visual Studio Code is on the left hand side. So this is the IDE we are going to use for Angular development. When we look at the Angular application, we have the node modules folder, which is just a folder to get all the dependencies needed by the Angular application. So we can completely ignore this folder for now. It's not basically part of the project at all. All the necessary files reside in the source folder over here. We have the app folder, the assets folder, and the index.html file as well. So things start with the index.html file. If you look at it, we have the basic HTML setup, and inside the body we have the app-root component. If you know that Angular comprises of multiple components, and this is the component that Angular is rendering by default. So components live inside the app folder over here. So basically, if you look for the app root component, is going to the app folder, and in here we have the app component files, which are the CSS file, the HTML file, the spec file for testing, and the TypeScript file. So we are keen in knowing the TypeScript file for sure. So if I open that, we have a selector that is app-root, and this is how the index.html knows that we have to call the app root component, because that is the selector, and this relates to the app component.ts file over here. So that is the selector we have. And another important thing in the component.ts file is the template URL, that it points to the same folder and it's pointing to the app component.html file. So the template is basically our HTML and styles are our CSS files. So we have all this component information in this component tag of this component.ts file. And these are the three files: CSS, HTML, and TypeScript file over here. In the actual component class, we just are using the title to pass it back to the HTML file. So if you look at this title, this should be used in the HTML over here somewhere. Other than the component and the index.html, we have the assets folder, which will be used to keep static files like images or other CSS classes as well. After that, we have the main.ts, which is basically starting up the app module, which resides inside the app folder as well. So the app module is basically an important file or important class inside Angular, and it basically handles all the imports, declarations, and other stuff and other providers, and submits this, or uses this information to provide this to the entire application. After that, we have the app routing module as well, which will be used to create routes. And by routes, basically we will have a map between the route and the component that will get loaded when that route is accessed. We have another file called the style.css, which we can use to add the global styles which are used throughout the application. Otherwise, the local styles can also be added to the component CSS classes. So now that we have seen the files and structure of this Angular application, it is now time to run this and see what we get out of the box. So I'll go back to the PowerShell or command prompt or terminal window, and I am inside the project. So inside the UI folder, inside Code Pulse, which is this one. In here, I will write the command ng serve -- open to actually open the browser as well. So I'll run this command, and it may take some time for the first time when Angular is running, but it should be here soon. I by mistake typed server, so it should be ng serve -- open. Angular CLI then opens a browser and runs the application on localhost 4200. And here's the application. So the application just has some scaffolded HTML which comes from the app component, and there are just links to Angular documentation. So we wouldn't be needed all of these. We would actually clean this beginning page, and we'll start to create the components. So we'll come back in the next lecture and we will create our first component. In the last lecture, we saw the files and folders that were created by Angular CLI as part of the scaffolding, and we also ran our Angular application, and this is what we get by default. Now in this lecture, we are going to clean this application so that we have a blank slate, and then we are going to create a new component in Angular. So for that, let's come back to Visual Studio Code. And inside the source folder, we have the index.html, and that is pointing to the app component. So let's open the app component, and we have the app component HTML, and all that screen or the website that you see over here is basically pointing to this HTML code. So you have the style, the CSS files, and then the HTML code over here, all in this file. So what I will do is select all of this HTML, but exclude the router outlet and delete that. So I'm only keeping the router outlet because the router outlet is responsible to display the components that are rendered from the app routing module. So with that change, I will save this file, and if I come back to the browser, we have the localhost 4200. It refreshes automatically because Angular knows that we have saved some changes, and it does an automatic refresh. And now we have a white blank slate. Now we are ready to create our first component. In our application, we are going to use the popular Bootstrap CSS framework, and to do that, to install that in our application, we are going to use its CDN. So we can navigate to Bootstrap, and this is the website, and that is getbootstrap.com. Alternatively, you can go to Google and search for Bootstrap, and you will enter this page. From here, we can go to the docs, and we have the get started section over here, or on the home page, I think we have, if you scroll down, we have the include via CDN links, and that's the approach we are going to take today. And that's the easiest and the simplest approach, and we can just quickly add Bootstrap to our Angular website and be up and running in no time. So we have this CSS file, which is the link. So I'll copy that, come back to Visual Studio Code, and open the index.html file. Inside the head tag over here, just before it ends, I will paste the link that I copied over here. After that, we also want the JavaScript file for Bootstrap, and that is the second link over here. So I will copy that, come back and paste it again inside the head tag over here. So these are the two links, one for CSS and one for the JavaScript file that we need to run Bootstrap inside our application. To confirm that we have correctly installed and are able to use Bootstrap, I will temporarily create a HTML element, let's say a button, and give it a Bootstrap class of button-primary. And let's call this a button. Save that, and if we come back, we should have our changes reflected in the Angular website. So if I refresh this, we have a button and we have the styles that Bootstrap gives us out of the box, and that confirms that we are able to use Bootstrap in our website. So I will delete the temporary button that I created, and now we are ready to create the first component that will be the top navigation bar in the next lecture. In this lecture, we are going to create our first Angular component, and we will start with the top navigation bar component. If you look at this diagram, the black outline, the black rectangle represents our website. And in our website, the red rectangle represents the navbar component. And if you imagine a blog, the blog will have the navbar component on every page because that's the area where users can navigate from. The yellow part of the application represents the components that will change based on the route. Hence, we have the router outlet keyword in our app.component.ts file. So when we create our navbar component, we will have that in the app.component.ts file and basically have that fixed, and the part in yellow will change and we will render components based on the route that we take. Our navbar component will look something like this. On the top, you can see we have the name of the application, which is CodePulse. After that, we have the link to the home page if we are not on the home page. And then we will have a admin menu because the admin will be able to configure the category list and the blog post list, basically perform CRUD operations through this Angular app, and this Angular app will then communicate with the ASP.NET Core Web API that we created. So that will be a admin who will perform this job. On this menu, we will also have the login and register functionality, but that is a later part of this course. So first of all, let's focus on creating the admin functionalities, and then we move on to restricting this functionality only to admins. So let's come back to Visual Studio Code and create the first Angular component, and that is the navbar component. Inside app, I will create a new folder called core, and that will be the structure of the application because I believe the navbar is a core component, so that will reside in the core folder. So I will create a new folder under app and I will call this core. Inside the core folder, I will have a components folder. So another folder inside core called components. And inside the components, I will create the navbar component. For that, I would need a terminal window. So you can use a terminal window inside Visual Studio Code. If you go to terminal and click on new terminal, we get a terminal window over here. I have that minimized, but I can easily use the link over here and expand this. So now I will do all my terminal stuff to create components, to create services for the application from Visual Studio Code itself. And I will do the running operation of this application through the PowerShell window so that we have a separation and I know if the application is running or not. Now to create my first component, I want to go and navigate inside the components folder. So I am inside CodePulse, which is here. So I will say cd, go to source, then app, and I'm pressing tab as I am switching between folders. So source, app, core, tab, components, tab, and then I will press enter. So now I am inside the components folder over here, and in here I want to create my component. And the way to create a component, the command line to create a component is ng generate component, and the short form for that is ng G for generate, C for component, and then the name of the component. The name of the component, I will call it the navbar, and we don't have to write component but just navbar. So ng-gc navbar. Press enter and Angular CLI will create a component under this folder. So it creates 4 files inside the navbar folder. Inside the components folder, we have the CSS file, we have the HTML, the spec file, and the navbar component.ts file. Now I want to basically insert some HTML inside the navbar.component.html file. So if you look at the TS file, the TypeScript file, we have the selector as app-navbar, and this is the selector that we will use to render this component in other components. For example, we want to use the navigation component in the app component.ts file. So open that file or the HTML file, and just above the router outlet, I will write app-navbar and finish the tag. And this is where our navbar will appear, and later on we'll have the router outlet. Based on the route, it will render the component. So I will save that, and we only have this paragraph in the HTML. So if I go back to the website, we have the navbar works paragraph on the top over here. So this is how our navbar is now represented on the screen. Now we want to change this HTML and introduce an actual navbar from Bootstrap. So for that, I will go to the Bootstrap website. In the docs section over here, you can easily search for any of the components that Bootstrap provides us. So let's say I want to go for navbar, and I will click enter. And this is the documentation for the navbar, and they have really good documentation. So you can scroll down and copy the HTML that you want to create and paste it and modify as per your liking. So I will use this one over here. I will copy all of the HTML and paste it inside the navbar. Save it, and if we come back to the application, you can see that the navigation is now on the website. Now we will just change this as per our own liking. For example, I don't need the search and the button, so I will delete it. I will also delete the link and the disable button, and I will change this to admin. So first of all, I don't need this form in the HTML, so I'll remove this. Then I don't need the disabled list item, and I also don't need this link over here as well. So I will delete the list item here. Now I am only left with 2 list items. One is the home, one is the drop down, and I also want to change this navbar. So let's come back. Let's wrap this nav in a container rather than a container fluid. So I will take the fluid out of it, and this will be just a container. After that, we will change the name. So this will become code pulse, or any name that you have given to your application. Now the first link is home, and the second link will be the drop down for the admin. So I will change that to admin, and the admin will only have 1 link at the moment. So I can remove this. I'll comment the divider because I will later use it, and comment this as well. So the admin drop down will only have 1 item, and that will be for the categories as we saw in the screenshot. So this will be the categories. So on saving that, I will come back to C, and we have the top navigation bar over here with the home and the admin. So if I click the admin, we only have one navigation link which should go to the categories list. We don't have that component yet, but we will create that in the next lecture. In the last lecture, we created our first component, and that was the navbar component. And we also have a link in that admin dropdown, which should go to the categories component page. But we don't have a categories component page at the moment, so we will create that in this lecture. The categories component list page will look something like this. We have the navbar on the top already, but on this page, we will display a heading that will say categories list. After that, on the right hand side, we have a button to navigate to a different page from where we can add a new category. And finally, after that, we will have a table that fetches all the categories from the web API and displays it as a table. We will do the work for the category list page later on in the section. But before that, we just want to navigate to the add category page from that add category button. So let's create the HTML and the component for the categories list page and prepare the routing for the add category component. Let's come back to the application. We want to now create a different folder where we can create our components which represents features or pages. So inside the app folder, we will create a new folder called features. So inside here, I will create a new folder called features, and the features folder will have a category folder. So features folder will have a category folder. This category folder will have multiple components like add category, category list, or edit category. So we want to create a new component in this category folder. So let's open our terminal again and let's navigate to this category folder. So I'll go back. So I'm in core at the moment. So I'll go back one more time, cd ... I'm inside app. Now I want to navigate to features. So cd features, then category. And inside this category folder, I want to create a new component for the category list. And you know how to create a new component. We want to create a new component by writing ng g for generate, c for component, and then the name of the component, which will be category -list. So press enter after that, and this will create a new component called category list component inside this folder. Now that we have created the component, let's go and add some HTML like the heading and the button for the add category component. So I will go to the category list component.html file, open that and remove the default HTML that we get. Instead, we will write some HTML by ourselves. So we'll start with a div. So div with the class of container. So class of container. The container will have a h1 heading. So h1, and that will say category list. And this will have a class, which is again a bootstrap class of margin top -3. So empty -3. After the heading, we will have a div, which will have that button on the right hand side. So a div. The div will have a class of flex, so display it as a flex, d-flex, then justify -content -end to push the button to the right hand side. And again, this will have a margin top of 3, so empty -3. Inside this div, we will have the anchor button. So we will say an anchor list, and I can remove the href for now and have the label as add space category. And this will have a few bootstrap classes, so btn and btn-primary. So save this. I will add the href back because I want to explain how the routing works. So href is equal to, and we'll add that later on. That is okay. So save the changes, and it won't come up over here because we are not showing that component as of yet. Even if we click this, it's not going anywhere. It's just going to hash over here. But we want to now set up the routing for this category list component page. And the way routing works in Angular is that you have to define the routing in the app-routing.module file. So if I open this, we have a constant which is an array of routes. Now we have to add to this array of routes the route that we want to create. So let's, for example, say I want to view the category list component when I go to a path. So the path is important. So in this array, I will have an object. The object will have the first property as path. And in this path, I will say, if I navigate to admin/categories, then load this component. So I want to render the component category list component, because that's the component that we created just now. And the name is coming from the TypeScript file. So if I come back to the category list folder, the TypeScript file is the name of the class, category list component. So that is what we are mentioning in the routes over here. When I go to admin/categories, open up this. So if we want to test this out, I can just directly in this navigation, I can write /admin/categories. And if I enter that, it is loading the correct page for us, or the component for us. So it's showing the category list heading and the button, the same thing that we created. Now we just have to hook this navbar item to this page. So we can come back to the navigation, which is inside the core folder navbar component, and come back to the HTML. In the list item over here, the href is pointing to hash at the moment, but we know that it resides in admin/categories. So if we save that and come back to the website, refresh this. If I hover over the categories on the left hand bottom corner, you can see that it's going to localhost 4200 /admin/categories. So if I click this, the page refresh, and it actually went to this page. So I can show this again. If I click on this, it goes to the admin categories page. But you notice this refresh button over here, that if I click it again, the page actually refreshes. So it's not really behaving like a single page application as it should. So the trick over here is not to use href, because href will load the actual page it is going to. Instead, we use a different thing. Instead of the href, we will use a directive called router link. And that router link will be a directive that is used to create links or navigation within your application. And the way we write this is, I can remove this for now, and it will be router link is equal to, and inside double quotes will be the destination it wants to go to. So again, /admin/categories. So save those changes and come back to the application. And let's go back to the home page first. So if I now navigate to categories, which is going to admin categories again, just pay focus on this refresh over here. So if I go to categories, it now doesn't refresh, and it is now behaving like a single page application without giving the user an experience that it is leaving the page and re-rendering another page. So it is a smooth transition between, because it is actually just rendering this component in the application. The way router link can be written in another way is with square brackets. And we will use this convention because then it becomes easier for us to add other parameters to the route. So instead of this, inside double quotes, we will say in square brackets the first string, which is /admin /categories, and then you can put a comma and add other informations to the route as well, but that is for later. But now we can use the router link to navigate to the categories component. So one more try, you come back, go back to the home page, and then go to the categories list page. So our categories list page is now working and we are able to navigate to it. We will now create the add category component in the next lecture and also create the routing of the add category page from this page. In this lecture, we are going to create the add category component and we'll hook it from this button so that whenever this button is clicked, it goes to the add category page. So let's come back to Visual Studio where we will create this new component. And this component will go under features. Under the category folder, we have a folder already, or a component, which is category list. So it will be parallel to this folder. So make sure the category folder is underlined. So that's where you want it to be. And let's open our terminal. And inside the terminal, we want to navigate to the category folder, and it is already in that folder. So I am all right. So now in here, I will write ng, G for generate, C for component, and the name of the component, which is add-category. Press enter to create this component. Now Angular CLI has created the component for us, and if we expand on features, we have the category folder, which also has these two components. One is the list, which we created in the previous lecture, and this is the add category component, which we just created. Now we will work in the HTML of this component, but before we do that, let's quickly bind the routing coming from the button in the list to this add category component. So let's open the HTML, which is the category list component HTML. And in here, we will define a router link, not an href, but a router link inside square brackets is equal to, inside square brackets and then a string. It will go to /admin /categories /add. And this will be the route that will be used to navigate from this list page to the add category page. But we haven't defined the routing of this component in the app routing module. So we can close this and open the app-routing module TypeScript file. In here, we have to define the path and the component combination so that Angular application knows where to go. So another object, and this is the array of objects, so it can have multiple objects in this array. So in here, we will define the path, and the path was admin /categories /add. And whenever we reach this URL, it should load the component add category component. So this is the component that gets loaded when this route is reached. So we can now close this app routing module. And if we open the application, it must have refreshed by now. So if we hover over the link, you can see it on the left hand bottom corner. If we click that, we can see that the add category works HTML, and this is coming from the add category component. So now it's time to work in this particular component. So let's come back to the application. For the HTML of the add category component, we would need a heading, and after that we need two input elements, one for the category name and one for the category URL handle, and then a button that submits this form. So now that we know what we are trying to achieve, let's come back to Visual Studio Code and write this HTML. Back inside Visual Studio Code, we are going to open the add category component and specifically the HTML file in this. And now we can remove the default HTML code that is generated and start with the container. So I will create a div with a class of container. So you can put a dot and press tab and it creates a class. So div with the class of container. After that, we need an h1 tag, and that will have the heading of add space category. The h1 tag will also have a class which will have a margin top of 3. After that, we will introduce a form which will submit on a button click. So let's create a form, and we can for now remove the action attribute from there. Inside the form, we will have a div which will have a class margin top of 2, so to have a top margin. And after that, we will have the div with the class of margin top 3. This will have a label and has a class of form hyphen label. That's a bootstrap class. The label will say category name. That's the value of the label. And with the label, we'll also have an input element of type text, which will have the category name, and we will give this a ID as well. So we'll have the ID as category name. We will have a class of form hyphen control, which is a bootstrap class, and we will also have a name attribute of category name. And with that, we have defined one input element which is for the category name. So I'll copy that and paste it one more time, and this will be the input element for the category URL handle. Because if you remember, there is only 3 properties for category, which is the ID, name, and URL handle. So we want to submit this request to the API, and we won't pass the ID. So we only need the category name and the URL handle for this. So I will change the label. I will change the ID to say this is category URL handle, and also the name to be the same as the ID. If we save the changes, we can come back to the browser to see the changes that we are doing that is getting reflected over here in the form. Now we need a button that will submit this form. So we need a button. Let's come back to Visual Studio, and along with this div, we will create one more div with a class of margin top hyphen 3. So class empty hyphen 3. And this will have a button which has a type of submit to submit this form, and a class of button and button hyphen primary, which are bootstrap classes. This button will have a text that can say save or submit, whatever you prefer. And this will be the button that is going to be used for submitting this form. Now we want to basically submit this form and capture the values inside the component.typescript file. But how to do that? For this, we are going to use template forms that are provided by Angular. So let's see how we can do that. Let's come back to Visual Studio Code and open app.module.ts. In here, we want to import a module that is responsible for submitting these forms, and that's called the forms module. So I will write forms module over here, press enter, and this will import forms module from Angular/forms. Once we have done the import, only then we can use the forms module inside the components of our application. If we try to use the form submission without this, it won't work, and it will actually throw an error as well. Now to complete our form submission, I can save this and I can close the app module file. Back inside the add-category component HTML file, I will give this form a variable name. So hash form creates a temporary variable is equal to ng form, and this ng form is basically coming from forms module, and it tells that this is an Angular form. Now that we have defined the form, we also want to create an onSubmit method for this form. So when we submit this form, we want to actually start a method call. So for that, we will use round brackets, and this is an event, and we'll use the ng submit event, and we will say on this submit of the form, we will instantiate the method on form submit, and this is a method that we will create. It doesn't exist at the moment, so we will create this method inside the TypeScript file over here. So let's open the add category component TypeScript file, and inside this class we have to create this method. So let's create this method, which is on form submit, and the name could be totally different, so that is all okay. So this name has to match this name, and you can define this as or your own. Now that we have defined the method, the red squiggly goes away because it is able to know that this method actually exists in the component file, which is here. So now we want to capture the values of these two input elements, one for the category name and one for the category URL inside this form, so that we can submit it to the API. But how to do that? For this, we will use the two-way binding that Angular provides us. We will read the values coming from the input elements of the HTML back inside the component.ts file. To do that, we will create a model, and for the model, let's create a folder as well. So I am inside the category folder because that's highlighted. In here, I will create a folder called models, and the models folder will have different types of models. The first one we would need is the add category request model. So inside the models folder, I will create a new file and would call it add category request model.ts, and that's the convention we follow when creating models. And inside the model, it will basically be an interface. So we will write export interface add category request and open and close braces. So this will going to be our model, and this model will have two properties. One will be name, which will be of type string, and after that we will have the URL handle is also of type string, and these are the only two details needed by that form to able to collect the details and pass it to the API to create this category. So we will use this request object inside the component. So we are back inside the add category component.ts, and in here we will create a new model. I'll call this model, and that is of type add category, not the component but the add category request. And we have to initialize the model because it says the property model has no initializer and it is not definitely assigned in the constructor. So let's use the constructor to initialize this model. So for the constructor, you can say constructor open braces and curly braces, and in here I can say this dot model is equal to new object, and I'll say the name is an empty string and the URL handle is also an empty string, and this will initialize the model that we have over here. And now we basically have to apply two-way data binding and bind this model object with the HTML so that we can later on get it back inside the onForm submit method. So the way to bind the model inside the HTML is to use square brackets, then round brackets, and write ng model is equal to the property that you want to bind it against. So that property is model.name, because this is the category name and we want to bind it against the name property inside the model. That's why we'll say ng model is equal to model.name, and this is two-way data binding. In two-way data binding, the value of this name is actually coming from the initializer over here. Let me change this to Samir. What do you think will happen? This model and the name value Samir is actually coming and displayed inside the input text over here. To prove that, I'll go back to the browser and you can see that we haven't typed anything in, but it still displays the value of the model name over here. Now I can revert this back to empty list, and this will still obey two-way data binding, because when we submit this form, the property name of name is now populated in this model, and we can actually console this over here to prove this. So let's console log this dot model. Now to test it, let's go back and right click and inspect this website. I'll come to the console tab, and in here I will write, let's say Samir Saini, it could be just anything, and I'll save this, and I can see in the console that there's an object with the name property as Samir Saini, but the URL handle is still null. And even if I bring anything over here, let's say this is a test, and submit this again, we can still see that the URL handle is empty because we haven't applied two-way data binding to this property. So let's quickly do that. Let's come back to the HTML and apply two-way data binding. So ng model is equal to model dot URL handle. And if you don't see a red squiggly, that means everything is working fine. It is able to recognize the property inside this class. So now that we have two-way data binding for both these properties, if I now say this is HTML blogs, let's save that, and it says the name is HTML and the URL handle is HTML-blogs. So we are able to capture the values of these two input properties using template forms, where we are submitting the form and capturing the results inside a method. In the next lecture, we are going to use these values and create an Angular service to actually send these values to the API. That is right, for sending or communicating with an external API, we use Angular services, and that's what we are going to do in the next lecture. In this lecture, we will create an Angular service and will submit this form and give data to the Angular service, where it will talk to the API that we created, the ASP.NET Core API, and it will submit the data using the Angular service. We will create a new services folder inside the category feature. So make sure category is selected, and we will create a new folder called services. So not here, but inside the category folder. So services, and inside the services folder, we will create this new service. So let's browse inside the services folder. So let's say cd services, and I'm now inside the services folder of the category feature. In here, I will write the Angular CLI command ng g for generate, s for service, and then we'll write the name of the service, that will be category, and press enter to create this service. So the service was created and it is inside the services folder over here. If I open the service, it is a class that is called category service, and it is basically injectable and it is provided in the root. That means this service is available throughout the application and in every component. Whenever this category service or component is created, it goes as a reference in the app.module as declaration. So you can see that the component is over here, and we also have the service injected in the root. Now for the Angular service to be able to talk to an external API, we use the HTTP client module inside Angular, and we have to first import that in the app.module.ts file, which is over here. So inside the imports array, after the forms module, I will write HTTP client module. And sometimes it just doesn't work because it's unable to import it, and we have to write the import statement ourselves. So we'll write import, inside the curly braces we'll say HTTP client module, and make sure the spellings are all right with the module over here. And this basically comes from @angular / common /HTTP and put a semicolon after that. So this way we have imported the HTTP client module and it sits in the imports array. Now we can close the app module.ts, and that basically means that the client module, the HTTP client module, is now available to be used inside components and services. Now, as we know that the mission of this service is to talk to the API, we will create a method that will be something like add category. It would take the request from the model, so let's say something over here from this model, and it will pass this request to the API using the HTTP client module. So first of all, let me create a method and let's call it add category. Now add category would take the model that we defined inside here. So this is the model and this is the type. So I'll copy that and we'll say it will take a model of type add category request, press Ctrl dot to add the import statement on the top. And as a return type, it will return an observable, and observable comes from the RxJS functionality. It is basically like a promise to which you have to subscribe to, and once you have subscribed, you can get the values from that observable. So it will be of type observable, and press Ctrl dot to import this from RxJS. And Angular and RxJS are, they just work very closely with each other. So the observable will be of something, and let's say this is of type void, which is empty. And after that, we will have to return something from here using the HTTP, because we want to communicate with the API or the external API. So let's say return this dot, and we want to inject the HTTP module, which is usually done in the constructor. So let's first inject the HTTP client module. So private HTTP, and this is of type HTTP client. And this comes from the HTTP folder as well. So press that or Ctrl dot and import it from Angular common HTTP. So now we have injected the HTTP client. We can use this over here. So return this .http dot, and it gives us various methods to either get or post or put to a different or external API. So we want the post call because the add category method is a post call. So we'll say post, return a type of void because we don't want a return from that method. And in here, it needs the URL which it has to go to. If we come back to Swagger, the one that we created our API in, we have the method defined in Swagger, which is the categories endpoint, and it is a post method API /categories. So this is the URL it should go to. So to get the full URL, it should go to this, because that is the URL which is my URL for the API. Yours could be totally different. And then API /categories. So in here, back in the Visual Studio Code, we want to go to a URL. So we will write in the strings. So this is the back apostrophe. So I'll say $, and I'll not say $, I'll just say the HTTPS localhost /API /categories. And I can remove this as a normal string as well, but later on we'll have to use this. So this will be a string URL. So this goes to API localhost categories, but after that we also have to provide the body, and the body is basically the model which we have defined, and make sure that the properties of the model matches exactly to how it is expected inside the API. So if I open the API, this is the category request DTO. The name and the URL handle has to exactly match how we have defined it over here. So the name and the URL handle. If it matches, it will return a success. So now I can say this, and that completes our add category method. Now we have defined the method, but we want to invoke this method from the add category component. So in the add category component, we first want to inject this category service because it is injectable and it is provided in the root. So it is available to this component if we inject it. So in the constructor, I will say private, the name of the category service. So category service, which is of type category service, and it's imported from the services folder. Now we have injected it and we can use it inside the onFormSubmit method. So instead of using the console.log, I can say this dot category service dot, it only exposes one method, which is add category, and to that method I can pass the model and say this dot model. Now let's put a breakpoint and make sure that your API is running. Otherwise, it's not connected to anything and it's not able to call the API. So make sure your API is running. I will put a breakpoint on the first line of this method so that we know when this method is called. And now that that's done and we have connected the service to the component, we will try to call this using our browser. So we will actually try to send values from the component to the service to the API. So let's say we have the HTML service. So HTML blogs. So let's save that, or try to save that, and see what happens. So if I save it, I have a breakpoint over here, but it is not getting triggered. Why is that? This is because if we come back to Visual Studio Code, I told you that the service method is a observable of type something, and observable values, they don't do anything on their own. We have to subscribe to their values for us to be able to trigger something. So for the service to be actually able to call the API, we would have to subscribe to this observable, and then it will actually trigger the call. So let's subscribe to this observable. So after the add category method, I will say dot subscribe, and this subscribe method takes an object in which we have 2 or 3 options. So one is next. Next is basically what happens next if it was a success response. We also have an error. What in that case, if it's an error, the call comes to this method, and the last one is complete. So if the process was completed, do you want to clear anything or do side effects of this method? So we will use the next method almost all the time. So next is then a method which takes a response, or which gets a response, such that open and close braces. So this is the format of the subscribe method, and we have the next, which will get a success response. You can call it a response or success response. Then we can put a comma and say error, and it is the same format. We get the error back, and such that an object. So you can do something over here when the error response is returned, or you can do something in this method when the success response is done. So in here we are working on the success response. So when that happens, we want to do something. Let's say when the success happens, we want to console.log and say this was successful. And that is it. So now that we have subscribed to the method, we would actually see the call actually going to the API. So let's come back to the application and do this one more time. Let's say this was a C# blog. Let's say C# -blogs. Save that. And we've got some errors on the console window over here. And it basically says course missing allow origin. So we have the thing says the same origin policy disallows reading the remote resource at this because of course. And course is basically a way of the API to protect its resources. We are going to know more about cors in the next lecture, and we'll see how to get rid of this. In the last lecture, we were trying to submit this form, but we got a cors error. And now we are trying to remove or get rid of this cors error by enabling it in the API. So let's come back to the API and stop the API. And let's try to enable cors. So let's come to program.cs file. And if we scroll down, we have to enable use cors inside the HTTP request pipeline. So when the HTTPS redirection happens, we want to say app.use cors, and it basically takes a policy name or some options using the cors policy builder. So we'll say options such that, and we'll say options dot, and here we can define the rules through which this API will work and will basically allow or disallow the requests coming in. So for our convenience, we will just say allow any header, options dot allow any origin, and the last one will be options dot allow any method. So using this, we are basically making our API public, but if you want to expose your APIs for some type of headers or for some type of origins or for only some methods, you would have to be more specific. But for our application, this is totally fine as well. Now that we have made the changes in the API, we will run the API again, and we will try to make a call from the browser, from the Angular application again. So we can see that Swagger is running. That means our API is running, and make sure it is running. So now we haven't made any change to our web application, which is the Angular application, and we were seeing this error before, but let's see what happens now. Let's try to send this request again. So let's do that. But this time it actually went to the API and it is stopped at the debugging point that we have. I can get rid of it now and let it continue because we have already tested this functionality. If you see the request, we are getting the name and the URL handle over here. So that means we are getting the correct request in the API, and the API should be able to create this category. So I let it continue. And this time we get a text back saying that this was successful, and this is coming back from the component and the subscribe method that we had over here. So we can say that our add category form or the page is working as expected. Because we are doing subscriptions over here and we are subscribing to an observable, it is equally important to have unsubscriptions. And what are unsubscriptions? We'll come back in the next lecture and understand and implement unsubscriptions for our subscriptions. In the last few lectures, we subscribed to observables because observables need to be subscribed before we actually use them and use the values that they can provide us. But it is equally important for us to unsubscribe from these observables. Let's see why. Unsubscribing from observables in Angular is crucial for proper management of memory, optimizing performance, preventing ghost subscriptions, and avoiding unnecessary network requests, and improving the code maintainability. So a lot of factors are there in the favor of unsubscribing observables. It can lead to memory leaks. It is always a best practice to unsubscribe from subscriptions when they are no longer needed to ensure the smooth functioning of your application. So let's come back to the application and unsubscribe the observable. So back into the app, we will unsubscribe from this observable, and it's very easy to do that as well. All we have to do is to create a subscription. So I'll create a private subscription. So let's say the subscription name is add category subscription, and this is of type subscription. press Ctrl dot and import this from RxJS and make it subscription or undefined. So by the question mark, we are marking it as a subscription type or undefined. So it's now time to use this, and we basically assign the subscription coming from the add category method, and we just say this dot add category subscription is equal to the value coming from when we subscribe to it. So if I hover over it, it's an observable and it returns a subscription over here. So we are actually assigning the subscription, and now it's all about unsubscribing from the subscription when this component is no longer in use. And we have lifecycle hooks for Angular applications and Angular components. So this component will basically implement the ng on destroy method. So let's say it says implements on destroy. Press Ctrl dot and import it from Angular core. So we have the on destroy, and we'll get the red squiggly because we are not implementing this interface correctly. So press or click the component over here and press Ctrl dot to quickly implement this interface, and you get the skeleton of this method. So I'll bring that to the end and still inside the component. So make sure it is still inside the component, and in here we remove this exception and we say we want to unsubscribe when we destroy this component. So we'll use the subscription again and say this dot add category subscription dot unsubscribe method, and that is it. So we have now unsubscribed from this subscription whenever the component is destroyed. This basically completes the add category functionality, and we have now implemented the add category functionality. In the next section, we are going to make use or create the API for the categories list over here so that we can display the categories found in the database, and we'll also work in the Angular application to display this in a table format. If you have watched this video till here, I'm pretty sure you'll love the entire course. Please use the link in the description of this video, which will give you an instant discount. The course has another 10 hours of development work in creating this application completely and covers a lot of other very important topics in great detail. So don't wait for it, click the link, and I hope to see you in the course.